Welcome to another Designer Getting Started video. In today's video, we are going to look at Exercise 5, Solid Preparation, Stock and Fixtures from the Designer Training Guide. You will be able to follow along using the training guide starting on page 72. We'll start out by opening the VDF file 5-Solid Preparation, Stock and Fixtures.vdf. This is the part we made in Exercise 4, Advanced Direct Modeling. We are going to use the copy command to copy the valve body to the Windows clipboard. Using the clipboard allows us to make copies of a part within the same file or to another file. From the Designer tab, select Copy. You can also access the copy command from the Quick Access bar or use Ctrl-C on the keyboard. Select the valve body and right-click to confirm. Now we can start a new file. Go to the File tab and click New. We will start the new file with a base for the fixture. From the Solids tab, select Cuboid. In the Options window, use Select 3 points and set the application point to Center of Rectangle. On the Options ribbon, make sure that Enhance Pick is selected. Select the workplane marker to start. Fill in the modifiers with 700 for the X distance and 400 for the Y distance. Use the Tab key to jump between the modifiers. Hit Enter to get to the height modifier. Fill in the modifier with 30 and press Enter. Right-click to exit the command. Now we can place the valve body from the clipboard. From the Designer tab, select Paste. You can also use the clipboard icon on the Quick Access bar or Ctrl-V on the keyboard. We get a pop-up menu to choose what layer we want the pasted part to go on, either a new layer or the current active layer. We will choose Insert by node name, which will create a new layer for the pasted part. Place the cursor over the right edge center point, but don't click on the point yet. In the modifier field, type in -190, 0, 470 and hit Enter. The valve body is now positioned above our fixture base. Now we will make some modifications to the valve body. From the Solids tab, select Cylinder. In the Options ribbon, make sure the filter Enhanced Pick is selected. In the Options window, use Select 3 points method and the Boolean operation is set to Unite. Place the cursor on the center snap point of the valve body flange, but don't pick anything. In the modifier field that appears, type in 0, 0, 5 and press Enter. Pull the cursor out and off the part, then type 180 for the radius in the modifier and hit Enter. Pull the cursor down and select the bottom face of the flange. The new cylinder is created and joined to the valve body. Right-click to exit the command. Joining the new cylinder to the valve body, change the color of the valve body. We can correct this using the Edit Properties command. Select Edit Properties from the Options ribbon, then select the valve body. Right-click to confirm the selection. In the Properties window, select the color line and pick a new color for the valve body. Then right-click to confirm and close the command. Now we will make another modification to the valve body to remove the radius at the end of the part. From the Solids tab, select Remove Face. In the Options window, select Remove and Heal from the Operations section. Pick the 20 mm radius at the end of the valve body, then right-click to confirm. Right-click to close the command. We have modified the part so that it could now be used as stock in a future operation. From here, we will start creating the nesting blocks for the fixture. From the Solids tab, select Cuboid. In the Options window, use select 3 points for the creation method and corner for the application point. Make sure the Boolean operation is set to none. In the Filters section of the Options ribbon, make sure Enhanced Pick is selected. Use the HUD is short for Heads Up Display, to position the part in a top view. Select anywhere on the existing cuboid under the 100 mm radius to the left to start. Pull the cursor down and to the right to the opposite side of the valve body to finish. Don't worry about the size and position of the cuboid, that will be adjusted later. I've rotated the view a bit so we can see the nest block better. Pull the cursor up and fill in the modifier with 140 for the height. Press Enter to create the block. Go back to a top view using the HUD, then repeat the cuboid process to create another block under the valve body flange. Again, use 140 for the height. Right-click to close the command. From the Solids tab, we will use the Boolean command to join the blocks we just created to the fixture base. Pick the fixture base as the target body. In the Options window, set the Boolean operation to Unite and make sure Retain Tool Bodies is unchecked. In the Options ribbon, make sure Multi-Select is on. For the tool bodies, select the two blocks we created. Right-click to confirm. While we are still in the Boolean operation, we can subtract the valve body from the nest blocks so the part will fit properly in the fixture. Start by picking the fixture. Then set the Boolean operation to subtract. We don't want to lose the valve body, so we need to check the Retain Tool Bodies checkbox. Pick the valve for the tool bodies and right-click to confirm. Then right-click to close the command. From the HUD, use the Attributes Visibility icon and select Invisible Entities. Pick the valve body and right-click to confirm. The valve body is now hidden and we can see our fixture more clearly. The sizes of the nest blocks need to be adjusted. To do this, we will use the Solids Move command. From the Options window, make sure the Offset Reblend option is selected. Select the front face of the left nest block, then right-click to confirm. In the pop-up label, select the Measurement menu icon. In the Measurement menu, select Use Ruler Dimension. Now select anywhere on the front face or edge of the fixture plate. Move the cursor to see the modifier. Fill in the modifier with 50 for the measurement and hit Enter. Right-click to confirm. This will set the edge of the nest block 50 mm from the edge of the fixture plate. Now we will repeat the process with the opposite face of the nest block. Select the opposite face of the nest block and right-click to confirm. Select the Measurement menu icon from the pop-up label, then select Use Ruler Dimension. For our reference face, we will use the opposite face of the nest block. Pull the cursor across the block to see the modifier and enter 300 for the measurement and hit Enter. Right-click to confirm. The block is now 300 mils long, positioned 50 mm off the front edge of the fixture plate. Now we will repeat the process to set the width and position of the block in the X direction. Select the left face of the nest block and right-click to confirm. In the pop-up label, select the Measurement menu icon. In the Measurement menu, select Use Ruler Dimension. Now select anywhere on the left face or edge of the fixture plate. Move the cursor to see the modifier. Fill in the modifier with 120 for the measurement and hit Enter. This will set the edge of the nest block 120 millimeters from the edge of the fixture plate. Right-click to confirm. Now we can set the block thickness. Pick the opposite face of the nest block and, using the same process as the previous faces of the block, set the thickness of the block to be 60 millimeters from the left face. The first nest block is complete. Using the commands we just learned, adjust the size and position of the other nest block. The right face of the nest block will be 150 mils from the right edge of the fixture plate and 80 mils wide. The nest block will be 10 millimeters from the back edge of the fixture plate and will be 380 mils long. The second nest block is now sized and positioned correctly. We want to add an additional nest block between the two that we already have. To make the third nest, we will use the Translate Feature command from the Solids tab. From the Options ribbon, make sure the Direct Filter is selected. In the Options window, set the Translation mode to Incremental and the Options mode to Copy Pattern. Window select the left nest, then enter 200 in the X-axis modifier in the Options window. Click the check mark at the top of the Options window to complete the command. You could also right-click in the graphics area to confirm. Click the red X to close the command. From the HUD, switch visibility to unhide the valve body. We have learned how to modify a part so that it can be used as stock, and how we can quickly create a simple fixture to hold our part. You can continue with this exercise on your own to add 2 clamps to hold the part. Here is an image of how the fixture should look when completed. Here are some things to consider. The clamps need to be the same width and length as the nest blocks. The clamps will need to match the shape of the valve body. They will need to have counterbore holes for M20 cap screws. And finally, the nest blocks need to have holes put in them to accept the M20 cap screws. Insert file workshop 3A-M20 capscrew.vdf for the cap screw. As always, we hope you found this Getting Started video helpful and would like to encourage you to explore all the features Designer has to offer.